Okay, let's get started. So last class we started looking at format string vulnerability, and in that format string 3 example, we captured the flag using the traditional sequential overflow. So we use the sequential overflow just like what we did in buffer overflow. But actually, format string vulnerability is more powerful than that. We don't have to do a sequential override. We can actually overwrite any location in the address space unless that location is writable. It's more powerful than that. So that's what we're going to do today. So this is format string level 5. The goal here is just to override a global variable. We have a global variable auth. There's a val is today somehow special? Why so many people didn't come today? Software or anything? No? Okay. So we have val will have a local variable buffer. Then we have a fgets. So the fgets will only take 510 bytes. The buffer is 512 bytes, so we cannot overflow that. After that, we have a printf. So there could be the printf use user input. That's where the format string vulnerability is. The main function has that vulnerable functions and just to check if auth is not 0. As long as it's not 0, it will print out the flag for us. Okay, so our goal here is very simple. We just want to overwrite the global variable auth and print out the flag. So any idea how we approach this one? We have an arbitrary right. Yeah. Exactly. That's what we're going to do. So we're going to get the address of that global variable. So we use %n to override that. So before we do that, let's take a look at the disassembly and the stack. So this is the disassembly of val, and on the right hand side we can say the stack. This one we do not have a stack canary there. So we have a buffer, 520 bytes, the saved EBP return address. Using that fgets, we will not be able to override this one. Okay. So what we can do is we can put the format string in the buffer. We can put it at the beginning of the buffer or anywhere in the buffer. That's where we input. Then when the function printf executes, the function printf will have its own stack frame, right? So it has its own return address, save the EBP like that. And it will look for parameters on the stack. So it will first look for the format string. If the format string has a lot of format specifiers, then it will keep looking for those parameters on the stack. So that's how we can fool the printf function to treat whatever we input there as the parameter for it. Okay, so let's see how do we do this one. We're going to work on level 5. So if we run this program, actually I changed the program a little bit. This program is a little bit different from what I'm showing here. At the beginning, I'm also printing out where is the return address, but for now, we're not going to use this. Later, we're going to use this. So you can ignore the return address for now. This is the return address of the lawful anyway. So you can say we can just input something, then it will print it out, whatever we input. The reason is, look at the program. It will use fgets to get our input from std in. It will be stored in that buffer. Then it will print out that buffer. Okay, so if we just give a regular string, it will just print out that regular string. Okay, that string can be really, really long, 500 bytes, and there will be no buffer overflow. So what we learned last week is if we do a percentage x or a lot of percentage x, we're going to view the stack, right? We can pick the stack, what is on the stack. So what we want to do is we want to put the address of the global variable at the beginning of the stack, the beginning of the format string. Then we have a lot of percentage x to move that pointer of that parameter eventually to make it point to our address. Then we use percentage n to write to that address. Here we don't really care the number we are writing, as long as it's not 0. So making things much easier for us. So let's say how we do it. First, we need to get the address of that global variable. So we can just do I need to make sure so we do grep this. Okay, so we have the address of the os. Now we are, let's do Python to say print. So we're going to print that address, put that address at the beginning of the buffer. Well, you don't have to put it at the beginning, but just for convenience, we'll put it here. The address of the global variable, auth. There's a global variable. Yeah. We're going to, so we can type this here. So if we pipe it here, it's going to print this out for us. The first one happens to be ASCII 4, so it prints out 4. So the others are not printable, that's why we do not print anything. Then we start to pick the stack by doing percentage x here. Our goal is to say what we put here. We expect to say 08043034. That's what we expect to say. Eventually, we're going to say it. We just don't know how many percentage x we need. So we just keep trying here. Is that it? No, not yet. Oh, that's it. The 4. The 4 is actually what we are. But we're printing out. No, that's not it. X. What is the 4? We put it 3, 4, 3, 0. Oh, looks like we didn't. Is this syntax correct here? Looks like this is correct. Okay, let's keep moving. Oh, it's actually here. See? 08043034. Okay, which means so those two don't matter. We don't need those two. We don't need those two. So this is where we get this. Then we can just so this, which means this percentage x, actually the corresponding parameter for it is this value. That's our address. So we can directly change this from x to n. Then we're going to use this address, and we're going to write something to that address. What are we going to write? What? No. percentage, when you use percentage n, it's going to write how many bytes the printf have already printed out here. So what we are going to write here is actually 1, 2, 3, 4. Oh, it's a little bit tricky because those ones, they do not have a fixed length. So basically the whole thing, let's say 1, 2, 3, 4. That's already 34 bytes. So it's probably something 50, around 50, right? I'm not going to count that. So we are going to write all something like 50. And it's going to print us the fact was. Okay, we don't know exactly the number, but you can see we can't control the number. So this is level 3. If we level 5, if we move forward to say level 6, then you will understand how we can control this number. So level 6 almost the same as level 5. We have 2 global variables. Valful almost the same. Main function where to make it easier for you, the main function print out the 2 global variables, and there is a check to check if the first one is 60, the second one is 80. Okay, sounds familiar, right? So almost the same as the first one, but things can get much trickier with this one. Let's try this one. Level 6. We're going to do Python. Oh, let's get the address of those global variables first. Oh. Okay, one is 34, one is 38. So now we construct our exploit. We can override the first one first, or we can override the second one first. Doesn't really matter. Okay. So here I'm going to override the first one first. The reason is the first one has a smaller number, right? So it depends on how many bytes we write, right? So we write a smaller number one, then we add a little bit of output there, and we go to the next one. But it doesn't really matter. Even if the second one or third one, the number is smaller, there are other tricks we can use to make it work. So this one, let's say we need 8 of those. The address is 34 C0 0408. Right? Another one is 38 C0 0408. After that, let's do this one instead. To make percentage 08x, so we always print out 8 bytes to make things cleaner for us. We need hold on, this one is wrong. 8x percentage x. Let's try this first. I'm not sure how many we need. Okay, then we can say three items on the stack. They are not what we're looking for. We're looking for 34, right? So we need much more. Oh, here we can add. Oh, from here. Okay, I'm printing out 6 items. Oh, we can see it here. So this one is exactly what we have here, right? Of course, I mean, if you feel it's hard for you to identify this, you just print something. Let's say you print 4 A's, then you look for that 4 A's. Well, whatever works for you to make it more standing out. Your goal here is just to try to find out which of this percentage X maps to the items in your format string. So that really matters for A's, for B's, or this value, because this value it's not easy to identify. That's what I'm saying. Make sense? So here, for example, I have how many percentage X? 1, 2, 3, 4, 5, 6. And here I have, then after 4 A's, I have 6 items. 1, 2, 3, 4, 5, 6. So I know this fourth item actually points to 4 A's. So this item points to here, right? So what I need to change is, so the fifth item, I need to change this one to percentage N. Okay, but there is a problem. I don't know how many I'm writing. We can run this because my program tells you we're actually writing 48 here. So which means from here to here, that's 48 bytes. Okay, but what we need is 60 bytes. This is easy. We can add more paddings here. We can add another 12 bytes of padding A's, right? That will work. Let's add another. It can be anywhere actually. Oh, no. We should not add that. And that makes sense complicated actually. How do we do this? Let's say, why adding this makes things complicated? When we add 12 A's here, what will happen is the fourth percentage X doesn't point to the percentage N doesn't point to that address anymore, because we have more things here. It were pointed to other place, right? So that's why adding this is complicated. Instead, what we can do is, well, you can still make that work, but it takes more time for it to debug. Let's say what we can do is here, we are printing out X and we are printing out 8 characters, right? We can print out 12 characters for it. No, 20 characters. We need 12 more, right? So we can print out 20 characters. Make sense? So I think that will make OS 1 to 16 to 60. Yeah. So see, we have previously, look at here, we have 6 percentage X, right? 1, 2, 3, 4, 5, 6, 6 percentage X. Those 6, they correspond to those 6 values. Maybe 7. 1, 2, should be 6. Oh yeah, here is 6. These correspond to those 6 values, right? Then in those 6 values, those are what we are picking at the stack. Then we try to find out which value is the beginning of what our input is. For example, here you can find this one, the fourth one. The fourth one actually is this one, which means the fourth percentage X points to the beginning of our buffer, which is the address we want to write to. So we just change that to percentage. Okay, everyone else get it? Okay. So here you can see we got this. We got the first one correct, but the second one we didn't override the second one, right? So now we also need to override the second one. So the second one, okay. If we do this, this time. If we do this, what will be the value of the fourth one? Fourth right now is 60. If we run this one, what will be the value of fourth one? Yes, exactly 61, because we have a lot of dots here, right? Okay, but what we need the auth to be is 80. So what we can do is from here, we add a D, then another 20. Okay, does that work? Does this work? Why? What? Exactly. This one will not work because this one, the percentage element, we're not going to here anymore, right? Instead, that percentage 20E will point to our address. The percentage N will actually point to here. So very likely that's not a valid address for us to write. So very likely this is going to give us a segment fault. Okay, see? So this gives us a segment fault, which means that actually here we need 4 bytes of padding, right? Make sense? Because we want a percentage D here. Then we need something to feed that percentage D. So we need 4 bytes of padding. We just put, maybe we'll put 4 zeros here. 4 zeros, okay. Will this work? Also doesn't work. Because after we add this 4 bytes, the address is correct. Even though this second percentage where it points to the correct address, but we're not writing 60. We're actually writing 64 because we add 4 bytes here, right? So this one will make the OS 64. Oh, 84, sorry. Okay. So because of that, we need to change this one again to 16. That's how we make it work. Oh, the first one. Oh, actually, we need to delete the first one, not the second one. So this one, the first one, we have the 20. We change this to 16. So this will work. Does that make sense? That's why when you do the format string, you have to do the calculation back and forth. Okay. How about everyone else? Well, at least at a high level, you understand what's going on, right? So after the class, you do this by yourself and also rewatch the video to understand this. But we can go through this again. So here we have 4 A's, which we don't have to use. And we know that we have 2%, between the 2% one, we have a percentage D, and it's a printing D. So we're actually printing between those, we're printing out 20 bytes. That's how we get from OS 60 to OS 180, that's 20 bytes. But because of this percentage D, we have to have something in the memory, to for this one to map to. That's why we add some 4 bytes of buffer here. The value of this doesn't matter, you can have anything. But we have those 2 addresses there. Okay. Let's move forward. So now we are going back to format string level 5. But now we're not going to overwrite the global. Yeah. So when we put the A first, there, yeah, you ask why we get this one, yeah, because that is just something on the stack. We don't know what that is, and we don't care. But actually we can easily tell what they are, right? Let's say this one obviously is like a stack, right? This one looks like a code address. This one I think is probably the return address. Okay, I can explain what's going on here. So this is a string. This string is copied on the set. This string has an address, right? The string's address is pushed on the set before printf. Because printf reads the address of the string, not the string itself, right? So when we are in printf, what we're printing out is, so we are picking a set, right? So we are actually picking from 4 bytes higher than what is the address of that string. Okay. But you know, between a stack frame of lawful and printf, there could be a lot of garbage. The compiler just put it or line or whatever. So here we are actually printing out some values we don't know what they are. So is this one? This may be the, what is that address? That address looks like, no, this is not stack. Stack should start with F, right? So that's not stack. That looks like a library location. That looks like an insert location. But this one looks definitely looks like the folks actually what we have that. Okay, I'm not sure what this value I'm saying is. Perhaps it's all the only two, but we can try to figure out what is that. That would be the address of that would be the address inside the wall folder. I'm not sure about this one. Okay. Yeah. We got figure out what's going on there. Any other questions? Okay, we move back to this one. But instead of overwrite the global variable, we are trying to get a fact without overwriting it. So how do we do this one? Yeah, we can write a with an address. Actually, we can write any function pointer in addresses. Sooner or later, as long as that function pointer code pointer is full, it's okay. Okay. So here, for simplicity, we just overwrite return address of the lawful. But there is a problem here. We can get the return address location. I put it out in the code. But there's another problem is we are going to override. Well, we probably do not have to overwrite all 4 bytes, right? Probably only need to overwrite 2 bytes because we already have a function address that we already have a main functions somewhere address in that return address. We probably only need to overwrite 2 bytes. What if we need to override 4 bytes? There will be a huge problem because the only tool we use to override something is %10. And we need to print out that number. We need to print out that many to write that byte. And we know those numbers are huge. Those are 4 bytes. Can we really print out so many characters and use %n to do that? It may take years actually. So it may not be doable. Okay. So instead, we do not override 4 bytes or even 2 bytes once. we write 1 byte, 1 byte. So how do we do that? That's so there is actually a feature of printf, the format string, to help us. I showed you last time there is a length before the specifier, and then you can use HL. So HH is actually 1 byte. So you can use percentage HHN to overwrite 1 byte instead of overwrite 4 bytes. You can also use percentage HN to overwrite 2 bytes, okay, to make this possible. So what is the idea here? Let's say how do we do this one? The idea is we can put our share code in the environment variable. So the share code is in the address space. Oh, we don't have to put a share code here, right? We just override the address to the print secret address. Yeah, this one we don't need the share code actually. Okay, then let's try this. This actually will be very tricky, not that simple, because the calculation we need to do. Oh no, which one is this? 5, not 7. Okay, let's see, what do we need? We need the address of that printf, print secret function, print flag function. So that's the function address. Also, by the way, the program tells you where is the return address stored on stack. Okay, I will show you the source code how I did that. Oh, no, not this one. To make our job easier in this challenge, I print out the address of that return address for the vol function, and to get that, I use the embedded assembly here. So you can see in this vol I define a variable called stack. It's a local variable. Then I will move the value of EBP to the first to %0, which is the global local variable stack. Then I just print out stack +4, because EBP +4 is where we store the return address, right? So so this is how I get where the return address is. So use the embedded assembly. You cannot get this in C code. That's why I embed the assembly code there to get this. Okay, go back here. So now we have this address. So what we want to do is we want to overwrite this address, line C, D6, FF. We want to override this address, right? But we're only overriding 1 byte using percentage HHN, because 4 bytes is not going to work. The number will be too big. So that's why we need to write it another address, which is 9D, 1 higher byte, and also D6, FF. Okay, so let's say when we can, what? So here we have 9C. We're going to override 1 byte to that. Then we are going to write another higher byte. That's 9D there, because we we want to write 2 bytes, right? Because of the most significant 2 bytes will be 0804. We don't have to change that, but we need to change the other 2 bytes, like this one, change to 92 and 36. That's what we need to do. Okay. Oh, we can actually swap them to make sense, to make our job easier, because this one has a smaller number, 36, right? So we can swap them. We write the second byte first, then the first one. Then let's try percentage x. Let's see when we can get this. Let's think. Oh, I have 2 hyphen c there. Should not have that. Okay. Do we see them? Not yet. Let's just print 4 more. Yep, now we say them. It's here. So we don't need the last 2. Let me get rid of those. Okay, we have those 2 addresses. So the first one we are going to, so we're using the same approach. We just overwrite the global variable. The first one we are going to overwrite to 36 in hex. What's that? In decimal. 54, right? That's 54. So this one we change to n. Then before that we should have 54. Let's see. So that's why this is important. We need to make sure they have the same size, but looks like they are bigger than 54. Let's say this is 4 bytes, another 4 bytes. That's already 8 bytes. And 1, 2, 3, 4, 5, 6. Ooh, 6. Then each of those are actually 9 bytes, right? Because we have a dot there. So that's already 54. Ooh, that's quite big. Looks like we need to overflow this. So to get to 50, so you see, when we print this out, we already have like 60 bytes something, right? So how can, but we want a 54. How do we get a 54, a smaller number? That should work. I never tried that. I don't think it works. I think the 08 here means the padding. Yeah, it should be at least or at most. Because the number is could be bigger than 4 bytes, right? That's what I'm thinking. So I'm not sure if it works. And we can try. Let's try. We do 4. It may work if they just show part of the number truncated. It may work. Let's see. No, it doesn't work. See, it's still printing out 8. Yeah. So that doesn't work. So the only way well, maybe not the only way. One way we can do it is we overflow this. Instead of what we need is 54, right? So instead of getting 54, we can get 54 plus 1 byte, which is 256. Right? So then we can actually print out 310. Right? 310. 256 plus 54. Yeah, that's 310. We actually print out 310 bytes. So what will be that? So that is actually 310 cannot fit into 1 byte, right? 1 byte can only hold 255. So it will be 2 bytes. The most significant bytes will be 1. The least significant bytes will have 54, right? but we're only overwriting the least, we're only overwriting 1 byte. So the overflow part, we just ignore it. Make sense? Okay, so let's say, well, by the way, let's add another 4 bytes here because we know we need some paddings later between those two. Okay, so let's count. So here we have that's why this one, when you hack this one, you need to pay extra attention here. You need to do the calculation carefully, and also every padding will add here will influence everything after that. So it's quite complicated. Let's say 4 bytes here, another 4 bytes, 8. Here we have 12. From here is 12. From here, each of those is 9. 1, 2, 3, 4, 5, 6. 6. Okay, that's 54. That's 54. This is 12. That's 66. Right? That's 66. And the number we want is 310. 310 minus 66 got 244. Okay. So instead, so the last one, this one should not be 244 would not be enough, right? Because we minus another 8 here, so it should be 252, right? I think so. Well, obviously you can tell I didn't try this before class. Yeah, last time I did this one is already last semester, and last semester we're not using a server, so things are a little bit different. Okay, so I think this is correct. Maybe correct. We can debug later to say if they are correct. Then between them, we have another percentage D. Then what should we put here? So right now we have a 310. We want to get what's the value we want to get? 92. 92 is what we want to get. 92x to decimal. So it's actually 146. Right now, what we have is 50, 54, 52, 54. So we need another 54, another 90, 92. Okay, we can debug. Sounds like right. Okay, let's try. Another 92 bytes. Let's see if it works. Nope, we got segment fault. Oh, we forgot to do percentage undo. Nope. Let's say percentage. Okay, let's debug this one. I think our calculation may be wrong, but getting there. We put this into our exploit. Then we debug this one. We run this. We redirect from the exploit. Okay, so where are we? Let's see. We are here. So we are going to, let's go to here first. Okay. Right now we are in fgets. So fgets should get our input. We do one more step then we quickly check if what we have there is correct. Let's do 40 bytes maybe. EBP minus 206, that's a huge number. Why do we have zeros at the beginning? that doesn't look like our input, right? What is our input? Our input should be this. Should be this. Oh, I made a mistake here. I piped this into this, then redirect to this. Okay, that was wrong. Okay, so what we should do is we get this into this. Now, okay, this looks correct. Now we debug this again. Also, can't remember. We redirect this exploit. So we still get a breakpoint here. No, not printf. This one. Okay, here. We continue. Say right here. Fgets. One more step. One more step. Then we exam. What do we have? Let's exam 40 bytes. EBP minus 206. Okay, this now is correct. That's what we expect. Now we are going to run printf. So printf is a vulnerable one. Okay, now we're here. Before printf, there is no overwrite yet. So if we examine the return address, we should get the correct one. So if we examine that, how do we examine? We examine x, maybe 4 bytes from EBP plus 4, right? That's where our return address is. So see, this is our return address. So if we can do a this main, so this address 9366 should be part of that main function. So this is the main function 9366. See, it's here. Okay, so this is right after the call to Valve. So that is a correct return address. So after we do that printf, we should overwrite. We should need one of this. We should overwrite this. Okay, but we have to overwrite it to the correct one, to that 9236, right? So let's just run one step to say if we write that address right. Ooh, it's all wrong. Oh, we forgot to do that HHN, right? Ah, yeah. Okay, so here, so looks like this one is right. Well, we're getting there. Yeah, we forgot to the. So here we're doing N, we should be doing HHN, HHN. Okay. Let's debug this again. Let's set Valve first. Run exploit. So let's just set a breakpoint here. We know the fgets works now. So we run this. Now we are at this. We print out, no, we exam that return address again, EBP plus 4. That's correct. Then we do it one step, should override this. Oh, it's reversed order. What happened? Our calculation is actually correct. It's just the wrong address there. So this should be easy. So we just swap those address. So this address should be C. This address will be D, right? That should work. Let's directly pipe this into the program. Yeah, it works. So in this example, we use the overflow to override. So you can see we can override any byte with any value we want, just with some simple tricks. So how did we get the address wrong? So this is the first byte. This is the second one. This is the least significant one. This is the second least significant. The value we're going to override is this. Oh, okay. We should not swap in the first place. The least significant byte has a smaller value, right? So we override that first. We get 54. Then we override the 92 hex. Well, doesn't really matter, right? If we swap those two addresses again, then we just redo the calculation. We overflow more times. We still can get the value we want. Any questions? Yeah. Exactly. So this percentage n is looking for those. That's why we do a lot of percentage x, right? So eventually the percentage n can correspond to the address here. Well, there are other ways. For example, this is just address. What if you just put the address in? Oh, no, you cannot put this on environment variable. Well, technically, yes. You put them in environment variable. Environment variable is still on stack. So with more xn's, percentage x, eventually that percentage n can still correspond to this one, right? The trick also here is use HHN. If we say there are 4 bytes, technically we can directly override that 4 bytes. But the number we're going to override will be huge, 0804 blah blah blah, 4 bytes. Then we have to print out that big number of characters. That would be very hard to do. Interesting. Let's see if it works. I haven't tried this for a long time. It should not work because the number is too big, but we can try. So in that case, we only need one address, right? We don't need 2. Let's say we get rid of this. We only need one address, one of those. Then we're not do HHN, we just do HN. Then we'll do this. Let's do X first, so we can get there. So percentage X here, which one? Oh, this one, the last one. Okay, so that is exactly what we want. So here we are going to do percentage N, but the number we have here is not big enough. We need a huge number. What is the address? What is the? Let's see. Hex to decimal. What is the number we're trying to write? 08049236, right? See, that's the number we need. Let's see if it works. I don't think. What the hell? Let's try. See? Well, I mean, maybe 10 years later it works. Who knows, right? Technically, it should work. Just take a long time. Yeah. That's why we do byte by byte. And then crashing. I probably crashed the container. Let's see. Okay, should be okay. I think after we exit, we are going to kill that container, so it should be okay. So how big is this number? Well, for all the 8 bytes, this is actually a small number, right? But this is also just 100 million, 100 million. Okay. So if you after we print out 100 million characters, we're supposed to get the effect. Okay. Cool. That's basically what I have today. Any questions? Okay. So we still have like 25 minutes. I want you to hack format string 7. You're going to use overflow. I think you will need overflow on this one. And it's almost the same as format string level 6. Just we have 3 global variables instead of 2. So try to figure out what are the numbers you are trying to override. Then I will walk around to help you on this one. Yeah, sure. How about this? You start working on 7, and I will go help you with 7. I don't think okay. Hold on. I mean, I can read it. No, then we what's your question? Which one you want to talk about? The one we just did? Yeah. Oh shit! I lost the export. Well, I cannot curse. This is recording. Whatever. Okay. So this one, yeah, I lost it. So what we did is something like this, right? We first have 2 addresses, right? We have 2 addresses. The first is no. There is no global variable. We are overwriting the return address. This one. So we're overwriting the return address, but we're not overwriting 4 bytes at once. We're overwriting just 1 byte each time. That's why we don't have to overwrite all 4 because we know the higher 2 bytes they are the same. They are 0, 8, 0, 4. We don't need to change that. Make our job a little bit easier, right? Then we're going to overwrite 2 bytes each time 1 byte, so we need 2 addresses. That doesn't really matter which byte we overwrite first. That matters. So here we put those 2 addresses here. So after that,
address we want to write and be higher.
It could be lower. We can swap those 2. Doesn't really matter. Yeah.
But now right into the address. I didn't really get.
That is a feature of format string. That's percentage n. Do you understand what percentage n does?
Yeah, it writes to a memory location.
Yes. Yes. Exactly. That's the memory location, right?
Yes.
So what is that value does it write? It will write how many characters are already printed out so far to there. Okay. That's why we have to do a lot of calculation. That's why we have the percentage d thing to do the calculation. Well, the homework will help you. The homework will start with easy ones, what we talk about on Monday. Yeah, maybe you can go back there to work on the homework. Start with first. Level 7 actually has 3 global variables, but I'm only printing out the first 2.
I will show you guys the source code of level 7, make science read a bit easier. The source code is a 4875 135. That's the values of those overrides. It's already 6:28, you can make if you want.